Modern AI systems present themselves as an impenetrable, flawless facade. From the outside, they look like perfect, all-knowing entities. Tech leaders like Sundar Pichai often point to massive, singular benchmark scores to signal progress with every new model release. However, many of these standard benchmarks are hitting a ceiling. Scores are becoming saturated, and in some cases, the metrics are being gamed by developers, leading experts like Andrei Karpathy to describe the current state of measurement as an evaluation crisis. The scores don't always align with reality. A model that achieves a 90% on a specialized medical exam might still fail to write a basic 10-word poem or correctly identify a dangerous prompt. There is no single metric for artificial intelligence. To see what a model can actually do, we have to look past the top-line grade and measure performance across distinct specialized dimensions. This chart shows the first dimension, the foundation. It visualizes perplexity, a metric that tracks how closely a model's predictions match the probability distribution of its training data. Beyond statistics, the second dimension tests raw memorization. Knowledge exams like MMLU use multiple-choice questions to quiz models on facts ranging from foreign policy to computer science. As models mastered those standard tests, researchers developed more difficult hurdles. GPQA utilizes questions written by subject experts that baffle non-experts, even with Google, leading up to the most recent challenge, humanity's last exam. Reaching these scores requires a model to ingest a massive volume of the internet, including millions of articles, books, and discussions from platforms like Reddit. Passing these exams confirms a model has successfully indexed a vast amount of human knowledge, but it doesn't prove the system can reason through new problems. This leads to the third dimension, instruction following. Here, the focus shifts from factual recall to how a model handles conversational nuances and adheres to specific rules. This UI demonstrates the Chatbot Arena, where users blindly compare responses from two different models. When a user clicks a vote button for their preferred answer, it updates a global ranking based on human preference. For a more objective check, researchers use IFEV. This benchmark ignores the vibe of the response and strictly verifies formatting constraints, like asking a model to write a travel itinerary without using any commas. The fourth dimension focuses on autonomous agents. Benchmarks like SWebBench and SciBench test whether an AI can iteratively solve software bugs or handle cybersecurity tasks over several hours. These tests measure the model's ability to execute professional-grade labor, but even the most advanced systems currently score below 20% on these tasks. The fifth dimension attempts to strip away language and memorization entirely to test pure reasoning. The goal is to isolate a model's ability to solve problems it hasn't seen in its training data. The ARC-AGI benchmark does this by presenting models with geometric patterns on a grid. To solve it, the AI must identify a transformation rule without any text instructions. The sixth dimension is safety. Much like the crash tests performed on new vehicles, models are evaluated through frameworks like HarmBench to see if they will comply with harmful instructions. This involves jailbreaking, using specific prompts and logic to bypass a model's guardrails. If a model can be tricked into providing instructions for a dangerous act, its safety protocols have failed. High performance in reasoning is irrelevant if a model is easily manipulated. Reliability in one dimension means very little if the safety dimension remains vulnerable. Accurate benchmarking assumes test data remains separate from training data, but because models train on the entire public internet, standardized test answers are accidentally included. This overlap creates contamination that artificially inflates scores. This reveals a gap in our current testing. Most benchmarks are just quizzing the AI on answers it may have already seen, while real users are asking the AI to perform original work in the real world. Evaluating AI has shifted from measuring isolated mathematical algorithms to observing the behavior of complex systems. When a new model is released, the most important question is no longer what is the score, but which specific dimension is being tested. As the field of AI evaluation continues to change, you can stay informed by subscribing to the Learn by Doing with Stephen YouTube channel. For deeper discussions on data and tech, listen to the Stephen Data Talk podcast on YouTube Music, Spotify, or your favorite